All right, welcome everyone to the October 2018 Nerves Remote Meetup. It is a small panel tonight, so me and Jon Carstens are on. We've each been working on kind of some sprinkler stuff and then moving on a little bit to other projects. So smaller crowd, but we'll just be talking about what we've each been building and what we've been learning from building some things in Nerves. And at least on my part, most of what I'm going to be sharing is mistakes I've learned. I've learned from things I wouldn't do again on my next project. But I think still worth talking about. So Jon, any thoughts here at the beginning of the meetup?
No. Wait. No, I was not muted. Okay.
No, we heard the resounding no. Well, do you want to jump in? If you want, I can lead first and kind of talk about the stuff that I did to put a web front end on my sprinkler system. We can chat through that first if you want, or we could go first with your garage door stuff.
You go for it.
Okay. All right. Well, let's see. Sharing screen. So let's do it this way. So I'll just share my screen. Minimize this. Lots of minimizing. All right. So prepare to be impressed. Badoom. That is, this is my UI. I'm obviously not a UI designer.
That's as good as my UI.
The good thing, I basically just made it really like kind of big and chunky, mostly for the sake of making it very easy to interact with, right? So
yeah.
So actually, zone 3. Oh, my sprinklers were apparently on. I was testing this right before this call, so this is good practice. Is it back on again? Let's find out. So the way I have things set up here, so I'm on the same Wi-Fi as the Nerves device. I still have the little SSH server running there that kind of comes with Nerves and Knit Gadget. We covered that in a previous blog post, but it is a super handy tool just in terms of being able to like poke around inside your system when it's running. So I'm just going to check zone 3 on sprinkler. Off. Okay. It's off. All right, now the UI is cleared. All right, well, that is actually accidentally a decent demo of the system. So the core idea here is that this is just going to live update. I used Drab for this. I did one version using Texas, but the desired outcome here is just that basically you can see the results. And I went ahead and just made it so that anyone on the internet, if you hit this URL, you can see the status of my sprinkler zones. That's not protected at all. But that if you haven't put in an auth token here, then any of these things you click on, it will actually try to send the command all the way down to the Raspberry Pi. But the Raspberry Pi validates that you actually know the token for taking control of it, so that not any random person on the internet is allowed to actually control my sprinklers. And so if we like turn on, for instance, so my zone 6 is not truly connected to anything. There is a physical relay connected to it, but it doesn't connect to any sprinkler valves. So this is a good one to like demo with. So you can see that it turns on. And then let's actually just do this real quick, just to get a sense of kind of what the lag looks like. So we can do something like 100 times each, and then we'll basically just say sprinkler valve turn off zone 6, and then we will timer sleep for a quarter of a second. And then we will blink sprinkler.valve.turn on zone 6. And so we'll just do that 100 times. And what you should see, oh, if I don't have typos, sprinkler valve. Valve. Holy cow. Apparently I can't type at all tonight.
I'm looking really hard.
Street zone 6. Oh, I did dot zone 6 on this second half. Sorry, this is like hard to edit in an SH channel. But anyway, so if it starts doing this now, actually, we also need to sleep after this one. Otherwise, you can't, it always looks like it's in one state. But if this starts going, then you can see this thing start to flash here in the UI. And if you actually pull up this thing, you can look at the network and see that we open up this Drab WebSocket, and you can see all these little messages getting pushed down.
Wow.
So what's happening here is that every time this thing sees a state change, it just kind of broadcasts an update about the new state. And those are going to a Phoenix app, and the Phoenix app obviously is hosting this thing. And then the Phoenix app, anytime it sees a change, it broadcasts it to anybody who is on the page for that sprinkler. So I named my sprinkler and my memories. So that's the basic functionality. And then if you do put in an auth token, and if I click zone 7, for instance, maybe I've flooded it with messages right now, possibly. But yeah, so if I click on zone 7 or click on zone 6, then I can't actually change them because I have the token put in there. So that's the basic functionality. And then the way I ended up implementing this, it took a few kinds of twists and turns. So, so mistake number one, I first started off by using a library called Phoenix Channel Client, I think is what it's called. Let's actually see. This is the PR where I switched away from that. Yeah, so previously I was using Phoenix Channel Client, which was just a convenient way of basically saying like, hey, I want to have a supervised socket connection. And then I want to be able to supervise actors that are joined to a channel and let them interact with that channel. And that works pretty darn well. The problem I ran into was that from the server, when the user clicks on a zone name here, and I want to like synchronously send that message down to the Raspberry Pi device and wait for a response, there's not an easy way that I could find in the Phoenix channels code to kind of wait for a response. So let me actually just pull up this code here. So the project that hosts the website, the Phoenix app, I call it home because I plan on hosting other kind of home-based devices out of here as well. And if I look at the sprinkler channel, where is this thing? Oh, I guess it's not really there because I'm not using it anymore in this project. No. So if we go back to this commit, okay. So as of this commit, I was, let's see, channel. So at this time, what I had was like the sprinkler channel like this. And if I have like this handle in, so this is, the browser has sent me a message, and then I would just always forward that on to, or sorry, this was the handle in coming from the Nerves client. So this was the channel that is talking to Nerves, and so I had this this registered actor called the Zones gen server, and this is the one that would kind of like handle all those updates coming in. And so it would receive this handle message, and the handle message would like parse out the zones from a JSON structure back into like structs, and then kind of keep that, as well as notifying of change, which did a broadcast. And this went to a Texas topic. So Texas is automatically using some channels, and I'm just kind of like nudging all the Texas channels to force a re-render. And so this is how it was. And the thing that I just couldn't get my head around was like, from within a channel, how do I now like receive a message into here and push it back down to my client? I mean, obviously I'm in a channel, I know how to broadcast to that topic. But then like, how do I wait for a reply to that? So from the client side, there's very much this concept of like, hey, I can send a message to the server, and from the server, I can handle in and just return a reply tuple here. And that will automatically generate a little reply JSON and send it back down to the client in a way that the client can treat it like it's a synchronous request. But as far as I can tell, there's not the opposite. There's not the idea of the server sending a synchronous request or initiating a synchronous request to the client. And so when I got hung up on that, it was also beginning of Hacktoberfest, and I was looking for open source things to do that might be of some benefit to other people. So I have this library I wrote a while ago, actually with several people who are in the Nerves Remote Meetup, called Nat, and it's a Nat's client, and it hadn't received any love in a while. So I updated a bunch of its dependencies and did a little bit of performance tuning, added some more tests, fixed a bug. And that got me thinking about like, oh yeah, Nats is actually this really easy way of treating all messages as asynchronous, so that the sprinkler controller doesn't even need to care about initiating a connection to a server. All it has to do is just connect to a broker and then just publish whatever it needs to publish. And it needs to subscribe to certain kinds of messages so that it can receive the commands. So that's what I ended up with in the Sprinkler project as of this PR. So you can see me pulling in the Nats dependency, and then the code remains pretty similar, actually. So now instead of a supervised Sprinkler connection and a supervised channel actor, I now have a connection supervisor, which will open up a connection to the broker and monitor it. And then this consumer supervisor registers itself to say, hey, I'm interested in topics like sprinklers.commands.mmreese. In other words, someone trying to send a sprinkler command to this sprinkler controller, and it will remain subscribed to that topic even if the connection goes down and comes back up, stuff like that. So this was all, this was good, and I have it all working right now. But honestly, after getting this far, it leaves a couple things to be desired. Like, so it's difficult, for instance, in the UI to have like a sense of liveness of this thing, right? Like if I go unplug my Raspberry Pi, it's just going to show the last known state of that device, but it doesn't know whether or not it's online or not. And I can't use like presence or anything like that to check if it's online. I would just maybe have to have like a last time I heard a broadcast from this controller. If you clicked on one of these zones, you would get a timeout because you would have published a command and never heard back about it. And so there is still like some sense of liveness there, but it's a bit diluted. So that kind of has pushed me back towards the idea. I think I might go back to WebSockets. and just try to solve the problem of how do I initiate a request response from the server side. So I'll look into that some more.
I mean, you could probably kind of semi-mock the behavior. It's not directly a request response, but if the client side sends a message, the server sends another message back, to expect the client side to terminate at that, if that makes any sense. Like with WebSockets, you're always pinging back and forth and you're defining the messages. And if you just know what series of messages should terminate or start conversation, then you kind of get, you kind of get close to that whole request response model.
Yeah, so kind of similarly, one thing I was thinking of here is at the time that the Nerves device joins this, I could like register my channel process, and then I could always just send a message to it with like a handle info to say like, hey, some browser somewhere tried to send this command, and then you can take an action on the socket in order to say like, oh, I want to just push a message down this socket, and I could just keep some intermediate state. I could add an assigns to this socket to say like, oh, I sent a request and I'm waiting for a response right now, and then I can time out if I don't hear back. And so I think that's kind of what I'm along the lines of what I'm thinking. But I'll also do a little more research to see if other people have tried to do this stuff and maybe there's existing patterns to follow there.
So was that your primary motivation from going from Texas to Drab? Texas seems pretty WebSocket heavy, and you wanted to use Nats brokerage. And could do a little bit more Drab, or
no? Yeah. So Texas and Drab, I mean, both of them would work with this thing just fine. There's a couple things that pushed me away from Texas. So one of them was that I guess I'll just say that overall it feels like Texas is a little bit less mature of a project. And the things that hinted at to me, for instance, are like, where was that? This thing right here. I couldn't find any way to actually make like a dynamic Texas subscription. So if you look at the code as of this version, let me actually see like, so my paid controller would basically do this thing where I say like, hey, I'm going to import Texas controller and I'm going to Texas render this template instead of normal render it. And then I basically use this little kind of shortcut thing. So paid view now has this function on it called data. And data always takes a con. And then what it's responsible for doing is figuring out like, okay, so what's the data that should now render in the template? And so in this case, like I don't have a good way to remember like which controller was I looking at. So in other words, as of this version of the code, I only had one controller, right? So the app was just like if you went to /sprinkler, you saw the sprinkler controller. And I wanted to move to a model where I could potentially have multiple sprinkler controllers, all being serviced by the same Phoenix app. But there wasn't a way for me, like if I added an assigns to the con here in this request, that same assigns wouldn't be in the con later on when this function gets called again, if that makes sense. And there wasn't a way for me to make the name of like my Texas topic dynamic. And so I couldn't just make it something like Texas : diffs : MMM It just had to be like something that could be figured out at compile time. And I think that comes down to some of the choices about Texas is trying to be super efficient about parsing out all of your kind of the dynamic partials in your view, and then allowing you to really efficiently re-render them and only send down like minimal diffs to the client. So there's that issue. And then the other thing is that Texas uses a cookie to track whether like if you're the same person that was there on the previous page. But one downside of that is that if I open like 4 tabs all to this same page, then only one of them would be live updating, because it's basically the last one to make the request now owns that actor in the backend. And it wouldn't push updates to all 4 of the tabs, which is like, again, it's not like the end of the world, but some of those things gave me the impression that Texas is still pretty young as a project. And Drab felt more robust, I guess. So if you look at the master now, you get a lot of similar concepts. So now when you render, you pretty much just do a normal render, but your index is a .drab instead of a .eex, and this is how Drab basically kind of injects itself into the rendering process. And then right here in your markup, you basically, so in Texas, when you have like, oh, this thing's going to get live updated, you basically put in a DOM element, but you don't put any content inside of it. And you put a little HTML attribute, which says, oh, this thing's going to be dynamic. Basically go ask the view to render this part of the DOM every time. And instead, Drab goes with this concept where like your template looks very much like a normal template. So all you're doing here is like a normal set of assigns, and you're just accessing those and looping over them to create LIs, and like very standard. It just looks like an EX template. And then what you also though now have to create this thing called a commander, and so it has to kind of line up with your view. But this is now it is kind of more of it's a little bit closer to just having an actor that's assigned to each tab. Each browser instance will have its own actor, and that means that you can do things like you can have a def handler here, and you can like have like on connect callbacks and stuff like that. So
def handler is a Drab callback, right?
Yeah, def handler is basically like the only reason you use def handler is that it's going to register kind of an event name of like, oh, I'm expecting a client to call me and to send an event with the name toggle, and then it'll route it to this function.
And that was in your view on one of the HTML elements, right? It was like a Drab toggle.
Yeah, so
or
these
Drab.
right here. Yep. Okay. And so what I've basically, you can just put a Drab attribute on any one of your DOM elements. And then you can just say like, oh, if this event happens in the DOM, then call this handler on the server side. And so then that gives me the ability in the commander, for instance, to say like, hey, I got a toggle, and so let me go build the command, and I pass in the event struct that comes in, and here I destructure the event struct to get like the ID of which element did they click on. So the IDs of these elements match the names of my zones. And then you can see I also like have a reference to the form that's on that page. And the class name I'm using in this case matches up to the sprinkler controller name. And so from those 3 things, then I can try to get like the auth token out of the form, which zone I'm toggling, and which sprinkler controller am I talking about. And I can kind of format or structure a little message here. And then I can just say, hey, home.zones, please send this command to this controller. And then this becomes a NAT publish with an expected synchronous reply. So it has a timeout and all that stuff. And you can just see, I basically just say, hey, if the status comes back 200, then this is your way of kind of pushing a status update back to the client. You just say poke and what key you're changing. And then alternatively, if I get an error message back, like, okay, then I'll push that error message back down to the client.
Cool.
So they're both really cool. I'm still really looking forward to Phoenix live views because I felt like it seemed to me from the demo, it's really hard to know because it's, we haven't seen the code, but it did seem like it's more similar to this model right here, where you basically just have a template that's a very normal template. and all you've done is like indicated that you want to have some sort of actor spin up that is going to keep a live status with this. And then I don't remember how he was handling DOM events and passing those back and forth, but there's still a little bit of weirdness here. So like, for instance, I wanted to always subscribe to changes about a particular sprinkler zone or a sprinkler controller set of zones. And the way I actually do that here is that on this connected callback, I call Phoenix pub sub, and then I have to just put myself into a loop because it turns out that all your callbacks are actually called in different tasks. It's not just like one actor that's backing your web session. It's actually multiple actors, and it like has tasks going on, these other things. I'm sure there's really good reasons for those decisions, but it means that I can't just like subscribe this process. I actually now need to like worry about keeping this process alive by going into a loop. And this was like the documented way of doing it on Drab's site. And so this feels a bit pokey to me. And so I don't know if the Phoenix team is going to have a better idea of how to improve on that kind of stuff. But I'm hoping that what we get to is basically you can treat the live view basically just like you have a channel, which is to say you basically just have an OTP actor. And so now it's just going to be one thing. It has its own PID, and you can just do whatever you want with it. You kind of have the whole OTP playbook of things that you can use within there. So I hope we can get to that point. And I think that's about it. You know, like I said, it's really minimalistic, but I will say the first time that I like clicked one of these things and I actually see the light up and I saw my sprinklers actually pop up out of the ground and start spraying, it was a magical moment. And then I made all of my kids take turns doing it.
Yeah.
And whether they wanted to or not doesn't matter. You know, like, hey guys, this is just a time to support dad and his hobbies. You all have to click this button and make sprinklers pop up right now. So.
Yeah, mine was basically the same. I waited until it was too cold to use sprinklers and I needed to blow my sprinklers out. But it was super convenient to have it on my phone because I was just walking around the yard. All right, that zone's done. Click or tap. Yeah. Next zone.
So by the way, this will be a segue into your presentation. But one of the main reasons that I'm actually super excited for you to talk about garage doors. So I recently started riding my bike to work. And when I do, it's like a 50% chance that I'm going to remember to grab the garage door opener out of my car because we only have two. So we have one in my wife's car and one in my car. And like, I'll either forget to put it back in my car or forget to take it out of my car. Either way, at some point, I'm going to be coming back to my house and be like, dang it, I don't have a garage door opener. Let me try to figure this out. And so what I'm really looking forward to is like not having to worry about that and just being able to like go to my phone and use some sort of like much stronger security practice than just the physical security of having this controller in your hand that like I could open my garage door from anywhere in the world, but I just have to prove that I have access to it, right? And so I am super excited for this. I'm dying to get to the point of like being able to control more of the mundane stuff around my house via all the other technology that I've learned to love over the years. So
yeah, so you're going into an office now. You're not just walking upstairs.
No, yeah. So we sublet this part of an office, $900 a month. We are a big deal company now. It's official. We have a water cooler, and yeah, feeling very grown up about all of it.
Oh, cool. Can you see my nice little keynote?
I was seeing it, and it just disappeared.
Okay, well then let's cancel that. Let's do just my screen.
Nice, I'm seeing it now.
Well, all right, so you can see it?
Yep.
Sweet. So let's talk about using nerves and controlling your garage door with my Open Sesame. So the actual opening part is really easy. Garage doors are not that intelligent, and to know if it should start opening or start closing, it literally just looks for a short in its line. So when you hit the garage door button on the wall and it's got the wires coming out of it, all it does is just short the wires across, and then the garage door starts to open.
So does it break the connection, or does it complete the connection?
It completes it.
Okay.
So it completes the connection, and it waits for that connection to break in order to trigger, if that makes any sense.
Okay.
So like you add to the line, but then you immediately take off.
And do you just, from a code perspective, do you basically just like trigger your relay, wait 100 milliseconds, and then untrigger it?
Yeah, exactly. My code's like wait between 250 and 500 milliseconds, and then put it back. And
nice.
Ta-da, it works. So that part was really easy. But then I wanted to know when my garage door was open and closed, so that I could have some checking to automatically close it for me if it was left open. And to do that, I found these little KY003 Hall magnetic sensors. Excuse me. Which are actually really simple. All they do is this little black head at the top detects a magnetic field, and if it does, it sends a signal. And if it doesn't, it's just a low signal. So, man, I don't have a pointer. That would be nice. Anyway, if you look at the sensor, that little top square, and it's got the 3 metal prongs coming out,
the one
you can buy, you could buy like a package of 100 of those for probably $10. They're super cheap. I ended up buying these because of this little guy right there. You have to, the return back needs a resistor on it, so you don't fry your board.
Okay, yeah.
And so this little R1 kind of pixelated piece is just a resistor integrated in this really super simple circuit. But even these, I got like 7 for, I don't know, $5 or $6. And then it's got this nice little LED, so it glows bright when it detects a magnetic field, and otherwise it's really dim. So yeah, very basic. So hey, I forgot I did this. So these are my very accurate depiction of my garage doors, brown with the squares and everything. And you got my cool little green pie over here on the right. So how I wired it to my existing pie that's controlling my sprinkler system is I made these wires for the sensor part. Actually, if we go back, if you'll notice, there's 3 prongs on here. There's a ground, a power, and a sensor.
Mm-hmm.
So that's it. So 2 sensor wires all the way across my garage. That was a chore. Pro tip, if you're putting up wire in your garage, do it with your garage doors closed, because it's way easier than if they're open. I was like trying to throw the wire across, but then it would get stuck. And so I had like rakes and stuff on the top of the garage door trying to get stuck wires. It was bad. But anyway, there's the sensor wire. But then I decided, instead of wasting a bunch of wire for the power, I actually split it and shared power and ground going to the Pi. So then I used less pins on the Pi and less wire in the garage.
Nice.
And then this was one of the cool parts. So what's the point of the magnetic sensor? Well, I mount the sensor to the wall as close to the garage door as I could. And then I put these little magnets on the garage door in the closed position. So when they're closed and I detect a magnetic field, then I know my garage door is closed. And and they're pretty sensitive. So even if the garage door is open like 6 inches, it'll, or even an inch, it'll say the garage door is open. Is that good or bad? I don't know yet, but it's good enough for the first round. So because I've got all this wire and I have to interact with pins, I did this nice, beautiful fake soldering with hot glue. So I just kind of shoved the wires into female to female ends of the wires and hot glued it. Ta-da! Because you know what? It's way quicker than soldering.
Oh, that's amazing.
Long term, it's probably better to solder, but like it was just so much easier. I didn't want to solder on the sensor because if one of these wires, something broke or I need to change something out, I want to just be able to pull them off the sensor. Yeah, there it is. Yeah. Hot glue works, man. In fact, dude, I even hot glued these sensors onto the wood of my garage. Yeah, if you look down in the bottom left, you can see one of the sensors hot glued right there. Oh, and the bottom right, you can find them. So yeah, this is my crazy, weird wiring setup and all my nice labels and using significantly less wire.
Dude, this is super awesome.
Yeah, it's pretty fun. Also, fun note, so my garage, I don't know if you could tell, if you look in the bottom right one, like it's not a typical rectangle. It has these angled wood facades, so you get kind of like a
in the corners.
Yeah, you get cut off corner look from the front. Another pro tip, you should look at where you should place your sensors according to the garage, where you would put a magnet on the garage first. Because I actually placed these and then I shut the garage. And you know how like those squares are beveled in? Yeah. Both of these sensors happen to be right inside that bevel. So I was like, I'm not going to wedge a magnet in a bevel. So
I was thinking on mine, I'm just curious if you think this would work now that you've done all this. I was thinking about putting the magnet on, so like you, in this left-hand side of the slide that's up right now, there's this track and there's wheels that the garage door kind of rides inside of those tracks. And I was thinking about putting a magnet inside of one of those wheels or attaching it to one of those wheels and then having the magnetic sensor just attached to the track right there. Do you think that would work?
Yeah, maybe.
I'll give it a try.
With these sensors, you had to put the magnets pretty close. And what I ran into, man, I wish I had a pointer. So that steel cable that pulls on the spring, that actually moves quite a bit. So I had initially was kind of putting them where you're saying, more like by the mounting brackets. But that steel cable would start really close to the wall and then end up right next to my track.
Yeah.
And it would move a ton and all the way up. So I couldn't really put a sensor at the bottom of the garage door. I can't remember why I couldn't do that, but there was a reason. Oh, like I couldn't mount any magnet close because of the cable so close to the wood and then towards the top. I don't know. But putting in the wheel.
Makes sense. I mean, it makes sense also not putting it at the bottom. I kind of initially was thinking that because my garage door currently has like a little infrared sensor so that you can't close it if there's kids running around, et cetera, right?
Yeah, right.
Probably a very good safety feature. I don't mean to minimize the importance of this safety feature, but it did occur to me that if I have anything that's that low, that means I have to run wires down that far, which means my kids are going to yank out those wires. And so then I was like, oh, can I put, like, what's the right way for me to put this sensor as close to the roof of the garage as possible? Because at least that'll put an obstacle. They'll have to really want to yank the wires before they figure out how to do it.
Yeah. I bet you could do it on the wheel, though.
I'll give it a try. I'll let you know if it works.
Yeah. I also really wanted it to be, like, I wanted it to detect a closed state. I wanted it to be the main. You know, you could put stuff all the way at the top for when it's open and you get a magnetic field and be like, oh, hey, it's open. But then if it shuts 2 inches and fails, then your sensor would say, oh, I don't see a magnet, so I'm closed, because it's only 2 inches away from me. So that made any sense. So definitely keeping it forward. Oh yeah, it's my video. So this is me testing out that after I glued. Oh man, it got it. Dang it. Wait, hold on. Oh no, dang it. Whatever. It glows, so.
I thought I saw it in like 1 or 2 of those frames. It seemed to be glowing.
Man, that's really unfortunate. Oh yeah, there's just a high another amount. The hot glue actually works really well, because when I had to move them, it was a chore to kind of rip it off and clean some glue off. Oh yeah, and here's my super precise placement on the door, the magnet on the door, also with hot glue. I mean, I thought it would be nice to drill in and have the magnet lay pretty flush with the wood. But I wanted to make sure everything worked before I start drilling into my garage door.
Good call.
And if you notice the green on the magnet, so because these are detecting, like a magnetic field is always polar, right? There's always 2 poles in the symbol of magnets. So it has to detect the change in polarity from one pole to another. So you will probably notice that if you just hold up a magnet to it, it may not trigger. You have to like position it in a way that it detects the field or between the poles or yada yada. So I would take one of these magnets and just rotate it until I got like a really nice detection. Like it would detect with a higher range of motion, which gave me like a larger window that I could place this magnet without it failing or needing to be extra precise. And so then I colored that half in and yeah. So there's a cool one. It's glowing big, which means it sees the magnet and knows my door is closed. That was actually very exciting.
Dude, that is so cool. Like
yeah, like you're saying, when you made your kids click the zones, I was in the garage and I was like, I am the master. I know my garage door is closed. And everyone's just looking
not
at me
because
weird.
I'm looking at it, but because of a magnetic sensor.
Yeah. Oh, that was it? Okay. I've got that video. You can still see my screen, right?
Yeah, I can see your screen.
I wonder what the video would look like. So, dang it. Does it have the sound too?
I'm not hearing any sound.
All right.
Does it make a little bit of a clicking, kind of like the relays do?
No, actually, it's silent.
Oh, there it goes.
Boom. Oh, in fact, maybe I should show a little my wiring. Actually, let me just move that out of the way. All right. Oh, you know what? I don't need the presentation. I can just hide that. So I'm going to show you how I was wiring to do the trigger. Can you see my mouse okay?
Yeah.
So these 2 wires right here, and I didn't get pictures of them, but these are like on the back of the garage door opener, like the actual motor. There's 2 screw points, and you'll typically notice that those have wires going out, and they go all the way to the button on your wall.
Right.
And so what I did is I just tied into both of those. I just added a line to each one, and brought it all the way down, and I just stuck it in the relay configuration, just like I did with the sprinklers.
Nice. In the normally open one?
Yeah. There's probably some cool electronic component to totally mimic what a garage door opener does. in in breaking the wire and connection and then reestablishing and causing it to open. But since I've already got this, I just put these two in, and then in fact, I can get the code up. And in the code, I turn it high and then turn it back to low 5 or a half a second later.
Yeah, I gotta say, like, so first of all, if anyone is watching this and they don't understand why you would stand in the middle of your garage and shout, "I am the master," I just gotta say, you gotta build at least one Nerves device and control something physical in the world around you before you totally write this off as just like craziness. Because there is something, like, if you've been doing software your whole life where it's server-side software, it's just, it's in a browser where like everything you do is a digital artifact. There's something really, truly magical about interacting with the physical world and seeing your code do stuff to the physical world. It feels totally different. So absolutely encourage people to give it a try. But I'll say one of the things that I've started to get this little feeling every now and then is I'm like, man, it seems like this garage door opener should have an API. Like, there should be some documentation somewhere about like how I check its state that it is in motion, or it is, or it's like partially open or whatever. And I'm like, oh yeah, like there's got to be a way to get to this. And maybe there is, but like no device manufacturers ever document that stuff, because like who was going to connect to a garage door and do this stuff? And that's not a market for them. So they're not going to take the time to like write up a manual and maintain documentation or support an API. But like that's kind of one of the wonderful things about doing these Nerves projects is now you do have all these things, APIs in your house, and so you can start to like connect them together. And anyway, it's super fun stuff.
Yeah. So when I was experimenting, because I've got an old garage door opener from early '90s, and I've got a newer one. I guess it's still like 2008 or 2009, but still newer. And the newer one, its controller actually has buttons for the light, has buttons to lock it, and all that jazz. And from what I was reading, a lot of that is controlled by the power or the rate at which it's sending the signal. So you could, like, I could make a bunch of relay connections, and they each send the desired amount, the desired frequency on the electrical line to tell the garage door that it's turning on a light or locking it or something like that. I kind of got at the point where I was opening and shutting and thought, I'm gonna leave this for now, and if I get real crazy, maybe I'll try to figure out how to send other signals and read other signals from the controller. I would like to be able to read those infrared sensors at the bottom to know if there's obstruction or something, because it would be nice. Like I with this magnetic sensor, I do want to have it detect and close after a certain period of time. But like if it keeps trying to close over and over because something's tripping the sensor and I don't know about it, like it's tripping the infrared, it would be nice to know, or say that condition of don't close it if there's an obstruction, maybe notify me or something like that. So lots of cool stuff to do there. Yeah. It's also funny when you look at all this and then you go, oh, I could just go buy one of these to integrate with my controller for like, I don't know, somewhere between $50 and $100, but it's a lot less fun than making your own.
That's so true. It's kind of like the first time I learned how to work on a car at all. Like if you change your own oil, your car runs faster. Like it doesn't, but you're sure it does. When you're 16 years old and you just changed your own oil, you're like, this is basically a performance vehicle now. This 3-cylinder Geo Prism is like, I'm riding in style at this point, because it's just like you did it, you understand it, you appreciate the elegance that is there in the existing design, and also you've made it better. And it's a different thing than just buying a product.
Yeah. So yeah, for the last step, I guess this is all the code I wrote to do and check for it. And it's very simple, but if you look right here, here's the actual triggering. So I did, this was like my quick and dirty way to do it. I would like to put these in a registry and make each of the, like the sensor and the opener processes, like the GPIO processes, supervise so that they auto recover. Where this is kind of a broken state, right? Because I use this garage door struct and I open these GPIOs, and if something breaks, I still have an old PID that's bad. But until then, this is all I do. Is just store these states of the garage doors in the gen server. Then I say, oh, okay, make it high, give it a second, make it low, and then boom, the garage opens.
I gotta say, I think it's awesome that you are those type specs.
These are these are suggestions. So this is the Elixir LS VS Code plugin thingy, and I can click it and add the type spec. I think there's a way.
I thought you had like taken the time to write in type specs, and I was like, wow, you're like, no. Yeah, you're not going to bother to supervise this, but you're like totally down to write type specs for it.
No, I mean it's kind of supervised. This garage door controller is, but no. I haven't figured out how to turn that off. Also, I haven't looked very hard, so I just kind of ignore it and keep working. But yeah, dude, I see doors, I trigger doors, and I can tell if they're closed or shut.
Bada boom.
And I would do a demo, but it basically is useless because you're just going to have to take my word for it that it worked.
I was thinking about the same thing for mine. I was going to go out and like hold my laptop so you could see the relays kick on and off, but like you can't even see the outside of my house. It's dark. So you could like maybe pick up the audio of the sprinklers turning on, but I was like, this is going to be a lame demo. I will say for our next meetup, or I don't know, the next meetup, maybe we get some other people to present. That might be better than me going back to back. But I'm actually planning on going in. So one of the teachers at my kid's school reached out to all the parents and was like, hey, if anyone has experience with engineering or software, we're looking for ways to kind of expose the kids to those types of careers. They were asking us to like send in just like a video of us answering some interview questions, but I asked if they'd be interested in me going in. So I'm putting together over the next couple of weeks a little RGB LED. So I bought like a little strip of RGB LEDs. I'm working on the Raspberry Pi integration so that I can control it from nerves. And then I'm planning on making it a little bit of kind of like a little brain teaser. And so I'm going to try to see if I can make the kids figure out how to like make all the lights this color, or make half of them this color, half of them this color. And I'm basically going to have like some physical buttons and some temperature sensors potentially, and let the kids try to figure out how those things interact with the lights, and then just talk about the pieces of it, right? And so I think that will be a more interesting demo to see on as a part of a remote meetup. And maybe it's a fun thing to do if you have a kid in school that is somewhat interested in this stuff.
Yeah, I think my son would really like that. Okay, well, if you could see my terminal, here's my playing with it and opening and shutting, and Stephanie asking me what I'm doing. But I trigger it and then I say, oh, I see it's still open. Oh, look, now it's closed. But to go along with your point, another thing that I have. So if you remember in the general channel, I'd mentioned how I wanted to start this library and I wanted to make really easily reusable and adjustable examples of these sensors. So I went ahead and made that library. And I haven't gotten very far. I've literally gotten basically just this. But I think it would also be really helpful to have something like that, because sometimes that's the biggest hurdle to get into hardware, especially with nerves. Like, how do I connect a sensor? How do I talk to it? What does it mean when it's a 1 or a 0? What is a resistor? Things like that. So I'm hoping to at least all the sensors I've done so far make these really simple modules that you can initialize it with the GPIO and then have some really common API like to read it and write it, or an example case that you could use it in, a little more documented.
I think that'd be super cool. I don't. I'm interested to see over time if it turns into more of a documentation project or more of a like getting started project, because I think like the Nerves Init gadget library has been amazing. Like I was still the other day, so when I was starting on this LED thing for my kid's school, it was like I did 30 minutes of work and I had a Pi that was auto connecting to my Wi-Fi and doing MDNS so that I could automatically find it on the Wi-Fi, and had an SSH terminal that I could push updates to. I was just like, oh my gosh, this is such an insane set of capabilities to start a project with. And I wonder if you can find enough common use cases that it's very useful, like people just leave it in their runtime, or do they mostly start with it as a way to get kind of poke at things and then end up replacing it with their own code. So I'll be interested to see how that plays out.
We'll see. What I've kind of decided on, especially based on the example of this magnetic sensor, is making some functions where you can not only interact with it, but you could give it like an anonymous function as an argument that it'll run based on messages it gets. So you could set the GPIO on to just constantly watch for changes, and then it'll loop and receive the messages, and based on what message it receives, like it'll elicit your function. That might make it more extensible where you could use it. So it could kind of fit, generally in both of those. A quick get started, and also maybe you could rely on it because you wouldn't have to rewrite a bunch of this stuff.
Yeah,
but we'll see. Like, I think my hope is if it works well, even as documentation and just to getting started, I'd be happy. But if it picks up a little bit more, that'd be way cool too.
Yeah, I'm hoping for the same thing. I think I'm going to start with blog posts, and I'm actually going to try and open up some PRs to some existing Nerve projects where I've noticed people kind of like build something that's pretty specific to their use case and just try to help make it more general purpose, and add documentation to those projects as I go. Because I totally agree that by far the biggest thing that stopped me from getting this far in Nerves previously was just like as soon as someone would say the word diode, I was like, oh my gosh, like I don't remember what that thing is. I don't remember what I need to be thinking about when I put it into a circuit. And anytime I can find a project where it's like, hey, here's an example of like how I wired it up to my Pi, here's how the code works, and you can just get to the point where you can poke at it and see it, and you feel comfortable spending $10 on Amazon to buy 100 sensors, then you're well on your way. Like then the project is going to flow after that. It's just kind of like getting over that initial hurdle of feeling like I'm not an expert. Do I really want to like try this? Do I really want to invest in it? And you just kind of have to get over that. But anything we can do to help lower that barrier, it's a good thing, I think.
Well, even this magnetic sensor, they kind of sat for a week because I got them. I was excited, but I didn't quite have a lot of time to spare. And I thought, well, if I get into this, I'm gonna have to Google, I'm gonna have to research how to interact with the sensor and all that jazz. It was literally you plug it in, and because it's input based, you plug it in and you put a magnet on it, and it's like lighting up or not lighting up. That was it.
Yeah.
Zero Googling needed.
Yeah, it's pretty amazing. And I think sometimes it's just hard when you're new to electronics like I am. It's just hard to know the difference. Like when I got my temperature sensors, they're pretty darn simple, but like I had to figure out the whole one-wire protocol, and like, does it call my code every time it changes, or does it just periodically publish something? Do I need to read the sensor? Like there's a lot of just little things, unknowns, and every unknown is just an excuse for your brain to be like, well, if I don't know how to do this, then I'll just go do something else instead.
Yeah, for sure.
All right, well, I'm gotta head out. I am very tired, but Jon, many thanks for your presentation, and thanks for getting me over the hump, because now I'm definitely going to go buy some magnetic sensors, get my garage door automated, and I will not worry about the garage door opener the next time I bike to work.
Yeah. I mean, if you got real crazy, you could somehow location base it off your phone and just open automatically.
Then someday I'll be walking by the front of my house and it's going to start closing on one of my kids.
Yeah, that's true. Yeah, maybe not a good idea.
It'll location sense me somewhat close, and then just as I'm pulling it under the garage door, then it'll close on me or something.
Yeah.
I know I would get that code wrong.
All right, man. Well, thanks for chatting. Have a good night.
Yeah, you too, and I'll see you next time.